Let's look at OpenStax College Physics, Chapter 21, Problem 69. A heart defibrillator being used on a patient has an RC time constant of 10 milliseconds due to the resistance of the patient and the capacitance of the defibrillator. A. If the defibrillator has an 8 microfarad capacitance, what is the resistance of the path through a patient? You may neglect the capacitance of the patient and the resistance of the defibrillator. B. If the initial voltage is 12 kilovolts, how long does it take to decline to 6 times 10 to the second volts? So let's write down the things that we know. We know that the time constant is 10 milliseconds. And we know that the capacitance is 8 microfarads. And in part A, we're looking for the resistance. Then in part B, we're given more information. We know that the initial voltage, so the maximum voltage on the capacitor, is 12.0 kilovolts. And sometime later, that voltage declines to 6 times 10 to the second volts. And in part B, we want to know how long it takes for the voltage to drop to that value. So in the diagram, just to remind myself, I'm going to draw a discharging capacitor. So initially it had a voltage V0, and some time later it has a voltage V. And this is a function of time. So in part A, I'm looking for the resistance. Well, I know that the time constant is RC, and I know both the time constant and C, so the resistance is time constant divided by capacitance. Time constant is 10.0 times 10 to the negative 3 seconds divided by the capacitance, which is 8 times 10 to the negative 6 farads. And when we divide the two, we end up with 1250 ohms. So 1.25 kilo ohms resistance. In part B, we know that the capacitor is discharging. So the voltage at a time t is going to be the maximum voltage times e to the negative t over tau. So just a little check here. Make sure that this is the correct equations. Remember that there are two of them. I know that when we are first starting at time t, the voltage across the capacitor should be V0. So if I plug in t equals 0, I should get V equals V0. So let's do that. If t equals 0 here, then e to the 0 is 1. 1 times V0 is V0, so then V is equal to V0, and this is the correct equation, the discharging equation. So I'm looking for t in here. So let's divide both sides by V0. So I have V over V0 is e negative t over tau. I want to get rid of that exponent, so I'm going to take the log, the natural log of both sides. So I'll have natural log V over V0 is natural log of e, so we only take the power then, so that's negative t over tau. So now I'm solving for t, and t will be tau, negative tau, natural log V over V0, and that's negative 10 times 10 to the negative third seconds. Natural log of V is 600 volts, and V0 is 12 times 10 to the third volts. So we plug these numbers into our calculator and end up with 0.03 seconds or 30 milliseconds. So it takes 30 milliseconds for the voltage in the defibrillator to drop from 12,000 volts to 600 volts.